Okay, page 1 of quadratics for math studies. Um, Use your results from the two previous investigations to help you sketch these graphs. Of course, the first thing we're going to do in math studies whenever they give us an equation is we are going to put it into y equals, and we are going to type it in to see what we get. 2x squared plus 1. And we're going to graph it. Usually the math studies graphs that we make are fine with the standard negative 10 to 10, negative 10 to 10 grid. You're going to have this grid automatically when you turn on the calculator and you've reset the calculator and you haven't modified it. But if you need to get this grid back, you could do zoom standard. Okay, so this is my first graph. Now, if I wanted to actually graph this, I should not just try to copy it off this screen. What I should do is I could press second table, and that'll give me many points which I can use to graph on my grid. And when I do that, you'll notice that if you go up from this point, you can actually see the negative values, right? Be careful, because if you go to the y side, it doesn't allow you to go up. It only allows you to go up on the x side. So, okay. So I'm going to get a few points off of this screen, and I'm going to write them into my grid, or my table, my XY table. So I'm going to put negative 3, 19, negative 2, 9, negative 1, 3, 0, 1, 1, 3, 2, 9, and 3, 19. Okay. I'm probably only going to use these numbers that up to y equals 9, because any more than that and it might go off the edge of the screen. Okay. Remember that when you draw the XY axis, some people have a tendency to always draw the X and Y axis right in the middle of the grid. But you can see that there are no y values that are negative. So there's no reason to draw the grid so high up. So you could either draw it like this, where the xy axis is right here at the bottom because there are no negative values, or you could draw it maybe with the origin right there. Okay, and this is a very nice grid because it's got dark lines every 5 units. It makes it a little bit easier to graph things. Okay, so I'm going to graph. I drew my axes in red, and I'm going to draw my parabola in blue. So first I'm going to draw the vertex, and you can kind of see where the vertex is because there is a unique y value here, 0, 1, right? And then 1, 3 would be there, and 1 or 2, 9 would be there, and 3, 19 would be there. And of course, if we reflect all those points around the axis of symmetry, we would have the rest of the points here. And then we connect them with a curve. Okay, so that is 2x squared plus 1. Let's try number 2. It's negative x squared plus 3. So go to y equals. We put in negative 2x squared plus 3. Okay, and this is the point. Oh, it's not negative 2x squared, but it's negative x squared plus 3. Now, this is the point where if you think that you know what you're doing, go ahead and try to do these problems on your own, pause the video, and just check your answer afterwards, okay? If you would like to see one more example, keep watching. So we're going to graph this. And again, the best way to copy a graph from your calculator to the grid is to not try to copy the picture. It is to go to second table and copy some individual points. So when I look at this and we saw the graph, we see that the graph actually goes kind of more to the negative side. So in this case, I don't think it's a bad idea to put the grid right in the center. And let's look at the table and get some points. So for example, we got -4, -13. We got -3, -6. We got -2, -1. We got 0, 3. We got 1, 2. We got 2, -1. And we got, maybe it'll be 3, -6. Okay, so let's graph those points. 0, 3, and 1, 2, and 2, -1, and 3, -6, and -3, -6, and the rest of them are all kind of reflected. So -2, -1, and I didn't write the -1. The -1 value would be -1, 2, right there. Oops. Okay. All right. We already knew that it was going to open down, right? Because if you look at this, we can see that there is a negative before the x squared, and we know that means the a value is negative, and we learned that that meant that it was going to go down. We knew that the y-intercept would be 3 because we know that the c value here, the plus c value here, is going to be the y-intercept value. So there's many things that we learned in our investigation which could help us verify that we drew the right parabola, but there's no reason not to use the calculator as an aid to initially draw the graph. So the next one I'm going to do is 3x squared minus 2. 3x squared minus 2. Let's graph that. As we suspected, it opens up because it's a positive a value, and it crosses at -2 because the c value is -2. Now let's go to the second table and write some of these values down. So the vertex appears to be 0, -2. We got 1, 1. We got 2, 10. We got -1, 1. And we got -2, 10. So let's graph some of those. So we got some negative values, but mostly positive values. So the vertex is 0, -2. There's also a point at 1, 1, -1, 1, 2, 10, -2, 10. Oops. There. Okay. That's it for that one. You can see that the a value is bigger than 1, so it makes it look narrower, doesn't it? Okay. Let's go to number 4. -2x squared plus 7. -2x squared plus 7. So this one's going to open down, right, because of the negative value here. So we could graph it first, kind of how we expected, right? We'll look at the table, and let's copy down some of these values to the grid. 0, 7 appears to be our vertex, and we got 1, 5, and we got 2, -1, and we got 3, -11. We got -1, 5, and we got -2, -1, and -3, -11. So it looks like we got some positive values, some negative values, so we'll just put the grid right in the middle. And we got 0, 7, which would be our vertex, 1, 5, -1, 5. We got 2, -1. We got -2, -1. and we got 3, -11. That's off the screen. Okay, so let's just go ahead and draw it. Kind of like that. I didn't like the right side. Kind of like that. Okay? All right. For the next section, you do not need to graph these. What value of x makes the part in parentheses 0? That is the x of the vertex because it makes y as small or large as possible. Okay, so do you remember the form called vertex form? If you remember, vertex form looks like this. Y equals a times x minus h squared plus k. If you remember, h and k are the positions of the vertex. The x-coordinate is the h, and the y-coordinate is the k. So if we look at this, we can identify the vertex and the axis of symmetry just from looking at it. If you remember, the axis of symmetry is the vertical imaginary line that goes through the middle of the quadratic or the parabola and divides it into two equal halves. So we could take this first one and we could say, okay, let's match this up with the vertex format. And if we do, we can see that k matches up with -2 and h matches up with, let's see, well, -h matches up with 3, right? So we got that -h equals 3, or h equals -3, and we got that k equals -2, right? So our vertex is -3, 2. Some people might look right at this format here and say, okay, I'm looking for x minus h, but it says x plus 3, so there's no negative here. You got to think of the plus 3 is actually as x minus -3. So if you think of it as x minus -3 instead of x plus 3, it's easier to see that the h value is actually -3. Okay? So in this case, our vertex is -3, 2. And if our vertex is -3, 2, we know that the axis of symmetry is x equals -3. And whenever you write the axis of symmetry, you write the equation of the line of the axis of symmetry. So you need to write x equals on the left, and you need to put the number -3 on the right. You can't say that the axis of symmetry is -3 because the axis of symmetry is a line. So you need to say axis of symmetry is x equals -3. And sometimes on the IB exam, if you do not put x equals, you're going to lose all the points related to that, and you're going to think it's really unfair. Okay, so in this next one, if we compare this to the regular form of vertex form, we can see that the x plus 5 matches up with x minus h. Let's see, x plus 5 is the same thing as minus -5, right? So actually the h value is -5, and the k value is 4 in this case. So the vertex is going to be -5, 4. And the axis of symmetry is going to be x equals -5 because the axis of symmetry is always going to have the same x value as the x value of the vertex. Let's go to the next one. So here we're going to match up again the vertex form with the equation they're giving us. And we can see that h matches up with 4. Perfectly, right? There's a negative here and there's a negative here. We don't even need to do that weird thing where we do minus negative something. And then the k value is going to be -1, right? So the vertex is 4, -1. And the axis of symmetry is going to be x equals 4 because it's the x value of the vertex. Just to emphasize that, if you look at the graph of a parabola, the vertex value is here, right? Do you see how the vertex is always on the axis of symmetry? So the x value of the vertex is going to be the same as the number which is used to graph the axis of symmetry vertical line, right? Okay. Two more. So on the next one, if we match this one up with the vertex format, we can see that the h value here is 5. So h is positive 5, and the k value is 7. So the vertex is going to be 5, 7, and the axis of symmetry is going to be x equals 5. Last one. So, oh, this is interesting. Now when we match up the vertex form, we can see something new. Do you see how the a value matches up with the negative sign here? So in this case, the a value happens to be -1. Now they didn't ask us about the a value. They only asked us to find the vertex, so we don't need to really worry about it. So if you see x plus 3, there's no minus sign there, and that might confuse you. But remember, x plus 3 is the same thing as x minus -3. So the h value in this case is actually -3, and the k value is equal to 4. So the vertex is going to be -3, 4. And the axis symmetry is -3, right? One thing that you might be able to do if you freak out on the exam and you don't remember how to do that, you could just graph it too, right? So if I wanted to, like, let's take this first one. I'm gonna type in exactly this equation. So x plus 3, and then I'm gonna put squared minus 2, and then I'm gonna graph it, and I can see that there's a vertex here, right? I don't know what the vertex is. There's two ways I could find it. I could do second table, and I could look to see, the vertex is going to be a unique point. Do you see how a lot of these points are repeated? The y values are repeated. So 7, 7, 2, 2, -1, -1. Why are they repeated? Because the parabola is symmetric and the y values repeat. But do you see there's one y value which does not repeat? -2. So actually -3, -2 happens to be the vertex, and indeed it is. See, -3, -3, 2 is the vertex. Oh, I wrote 2 here. It's -2. Oops. So I just discovered that I made a mistake there too. Okay. So do you see how sometimes doing it with the calculator is a little bit more reliable than doing it another way? All right, let me check real quick the others. K equals 4, that makes sense. K equals -1, that makes sense. K equals 7, yes. K equals 4, yes. Okay, the rest of them look okay. But do you see how you could use the calculator to do that? There's one other way. Let's say that for some reason you're unable to locate this unique point here. One of the ways you could do it is you could do second calc min and find this point here. The second calc min button sequence, it'll find the minimum point on the graph, and the minimum point happens to also be the vertex, right? If you have a vertex that opens up, you're looking for the minimum point, and if you have an upside down one, you're going to look for the maximum point. So let's do that real quick. We're going to do second calc minimum, and then when we do this, there's going to be a sequence you're going to do. It's going to ask you to define a left limit and a right limit around the minimum point so that it helps the calculator locate this minimum point. So first it asks for the left limit, and you just like move the arrow around, and you see the cursor right there. It's not to the left of the vertex, so I move it to the left of the vertex. Once it's clearly to the left of the vertex, I hit enter, and then I move, then it asks me for the right limit, so I move the cursor to the right side, and I hit enter again, and then it asks me to guess where in this interval the vertex or the minimum is, but it doesn't really matter because the calculator is going to be able to find it because there's only one minimum point here. So I just go ahead and hit enter, and then it finds the minimum point. It says -2.99999, -2. And we know that the real answer is -3, -2, right? But since the calculator is not actually finding the real vertex, it is using, 100 billion calculations to finally get the right answer. And the right answer from the calculator's point of view is close enough when it gets this close, okay? You're going to have an instinct after a while, okay, if I see -2.999999, that's actually equal to -3. And if you don't have that instinct, do this. You're going to calculate this to the nearest three significant figures. And so if you look at this, the first three significant figures are 2.99, right? But you have to look at the fourth significant figure, which is also 9, to see if you should round up that 9. And since it is something that would round up that 9, 2.99 becomes 3.00, right? So in the end, you're going to find that it's -3, -2 anyway. All right? Real quick, you can stop watching here if you're not interested, but I'm going to just show you how to do number 5 using second calc max, because remember, number 5 is actually upside down, right? So I'm going to delete this one. I could have done a clear also. And I'm going to put negative, and remember, if you have a leading subtraction sign like here, you need to put this negative sign, not the minus, okay? And then I'm going to put x plus 3 quantity squared plus 4. And then I'm going to graph it. And then it's going to be upside down parabola, right? Now I'm going to find this point by doing, instead of doing second calc min, I'm going to do second calc max, because this is a maximum point. So I go second calc max. And I know this is a lot of calculator procedures at the moment because you're starting out. But the thing is, there's only about 10 calculator procedures. And once you learn them all for this unit, all the other units are going to be really easy, because you're still going to use second calc max. You're still going to use second calc 0. You're still going to use second calc intercept. And there's none others. You're just going to do basically those and a few others. Okay. So now I'm looking for the left limit. That's to the left of the vertex. It's right there. Enter. I'm looking for the right limit. I'm going a little bit to the right of the vertex. Let's stop right there. And then it asks me for a guess, which doesn't really matter because there's only one maximum point here anyway. And it gives me -3, 4, which I already know is the answer for number 5. Okay? Now we're really done.